Hey guys, how are we going today? In this video we're going to have a look at the second part of finding volumes of particular shapes rotated about, the x, the y-axis, or even a different line. But we're going to have a look at a different method called volumes by cylindrical shells. This one we're going to take the slice not perpendicular like we did with the previous method. We're going to find the volume by getting the slice parallel to the rotation or the axis of rotation. Alright, so just say we have any particular function, doesn't matter what it is, any type of curve y equals f of x, and we're going to rotate this around the y-axis. So our domain will be from A to B. Take the thin strip parallel to the axis, and we're going to do this around the y-axis. Here's the y-axis, so we're going to do it parallel to the y-axis. When we get that little strip and rotate that around the y-axis, we get this cylindrical shell. It's like a cylinder with a part missing, but it's so thin that we call this a cylindrical shell. We then unravel that cylindrical shell. So just say we cut along here and unravel it, we end up getting a shape of a rectangular prism. A very thin, so that dx is, or delta x is very, very thin, and we end up getting the area of this face multiplied by that delta x to calculate the volume. Alright, so we now need to find out the dimensions of this. So this height is going to be the y value, which is that height there, which is the same as subbing in the function value. This length here is actually the whole way around. When you unravel it, you end up getting the length of that prism, but that is also the circumference of that cylindrical shell. And because this is quite thin, you might be thinking, well, there's a little bit extra, but because we're assuming that delta x is infinitely small, very tiny, that length is just going to be the circumference, which is 2 pi r, and the radius is going to be the x value, so that x value is going to be the radius. So the area of this is the area of a rectangle, length times breadth, and the volume is going to be the area multiplied by the depth, which is delta x. So the volume, by taking an infinite number of cylindrical shells, will be the same notation as what we had previously, but this is our expression. Writing it in terms of our integration, this 2 pi is a constant, can come at the front, and we end up getting x multiplied by f of x. Alright, we're going to have a look at this same example as we had in the first method of discs or shells, discs or washers, but now we're going to have a look at cylindrical shells with the same concave down parabola. So here's our concave down parabola. We have our x and y intercepts. We're going to rotate around the x-axis. So here is the x-axis, parallel is in this direction. Get that cylindrical shell going around the x-axis, creating a rectangular prism. Now this height is going to be, well, from here to here is x. So no matter where you go from here to here is x. So therefore that whole part is going to be 2x. And 2x, making x the subject here, x squared is the same as 4 take away y. So therefore x is 4 take away y to the power of a half. So this is where the x value comes in as 4 take away y to the power of a half. This distance here is when you unravel this, the circumference becomes 2 pi r, and this value here is y, so 2 pi times the radius is 2 pi times y. So the area of this face, length times breadth, length, breadth, and the volume is going to be the area multiplied by the very small thickness, delta y. Alright, so the volume is as delta y, or the limit as delta y approaches 0, finding the sum of going from the y values of 0 up to 4. So we're going from 0 up to 4, and then here is our expression, delta y. And then converting it into our integration, and then integrating and subbing in your values. So to integrate this, we can have a look at a bit of substitution. So if we want to substitute a variable in for here, and then expanding that out, and then subbing in our values. So I'll let you do the integration, this part here, as an exercise. I'm not going to go into that. I'm just going over the method of constructing your diagram, and then from your cylindrical shell into your expression for the dimensions of your rectangular prism. Alright, here's an interesting one. Find the volume of a circle rotated about the line x equals 4. Here's a circle. There's the vertical line x equals 4. Get a strip parallel to x equals 4. Rotate that around x equals 4. And we end up getting this shape that looks like a donut. And we call this shape a torus. Draw yourself a rectangular prism that mimics the cylindrical shell. Once you unravel that, what are the dimensions? So this becomes, well, the height here is the y value. There's another y value, so that's why we have 2y. Remember, we need to rearrange that equation to make y the subject. And then 2 pi r is that circumference, and 2 pi is there, and the radius is 4 take away the x value. So the radius is this part here to this part here, which we know this distance is 4 units, and then we're just taking x away. So that's why we have 4 take away x as the radius, because if you take the strip here, that x value is different. It's still 4 take away x as the radius. Alright, so the area of that rectangle is a product of those two. And just simplifying that somewhat. The volume is going to be the area multiplied by delta x. And our volume is going to be the limit as delta x approaches 0 from the sum of all the x values from -2 up to +2. If we expand out the brackets, we end up getting this expression. So 4 multiplied by this, and then -x multiplied by this. And then this is going to be a little technique that we have a look at. This is a semicircle. So it's 16 pi multiplied by the semicircle. Semicircle is going to be 1/2 of pi r squared. And the second expression is, here's an odd function, here's an even function. When you multiply an odd by an even, you ultimately get an odd function, like we saw with graphs. And with an odd function, I'll just go with a nice simple odd function like y equals x cubed. If we go from -a up to positive a and find the integral between that. Because of its symmetrical property, we end up getting a positive and a negative value. So when you look at going from -2 up to +2, those two positive and negatives cancel out to give you a total value of 0. So rather than doing the integration, remember you can use integration by subbing in an appropriate substitute, but using our knowledge of odds and evens, you can look at that quite nicely. And then simplify the semicircle component, and then we end up getting 32 pi r squared cubic units for that volume. Alright, I hope you got a better understanding of this particular method of volumes of cylindrical shells, which is the second component of this unit of work. Hope you learned something in this video.